Hi there, my dear students. How was your day? I hope you're in good shape and in good mood watching today's video lesson as we start diving into the mathematics of physics. This is still Miss I, your teacher for today, and I welcome you all to General Physics 1. Our lesson for today is about addition of vectors using analytical method in 2 dimensions. Still, this is anchored according to the DEPED's most essential learning competencies for week 1, and that is to perform addition of vectors. And at the end of this video lesson, you should be able to use analytical methods in addition of vectors.
So this time, before we dive into adding vectors, okay, and before we dive to the mathematics of physics here in addition of vectors, let us have a recall of our previous lesson from junior high school, okay? The difference between a scalar and a vector quantity. So scalar quantity is just purely magnitude. That's what we learn, okay? A scalar is a quantity that is fully described by a magnitude only. It is described by just a single number. Some examples of scalar quantities include speed, volume, mass, time. So for example, mass, 50 kilograms. Time, what time is it? It's 10 seconds, for example. And speed, let's say 20 kilometers per hour. So those are just scalar quantities. So what makes a vector quantity different from a scalar? Now, a vector quantity already now has direction. So it does not only have magnitude, but it has direction. So now it has magnitude and direction, okay? That's vector. So vector quantities are important in the study of motion because it includes now direction. Some examples of vector quantities include force, velocity, acceleration, and momentum. So weight, okay, is already a vector quantity. So now let us have some examples of quantities, okay, that are either scalar or vector. So for scalar, they have magnitude but they don't have direction. No direction. So examples are distance, speed, mass, energy, density, power, length, area, volume, time, temperature, and work. Vector quantities, they have both magnitude and direction. So examples are displacement, velocity, weight, acceleration, force, impulse, pressure, momentum, gravity, and drag. Drag is a force, a type of force, okay? Now, so we recall our scalars and our vectors, okay? So scalar, when you say 5 meters long, you only say 5 meters long. That's just a scalar. But a vector quantity is now complete by adding its direction. So you say 5 meters east, or you say 5 meters going north. How much or how far have the car traveled, for example? So you'll say it traveled 5 kilometers on the way to Dipolog, okay, like that. So going to Dipolog is already a direction. How do we add these vectors? Okay, now let us check our previous understanding, okay, because for scalars it's not that hard. We will simply add. So for example, how far has the car traveled? Then the given is 5 kilometers and 10 kilometers. Then you simply 5 plus 10 kilometers is 15 kilometers. That's simply scalar, okay? So it's very simple. You just add the two. But in vectors, we have to check first their direction. So for example, if you have 12 to the east and other 20 to the east, or you say 12 to the right and 20 to the right. So when you add that, 12 and 20 is 32, still going to the right or going east. Now, this is now the net distance or net displacement rather. Now, if you have 6 south plus 10 north, or let's say 6 meters south and 10 meters north. So you don't add the 6 and 10 and will give you 16. You have again to see the directions. Now, getting the directions involve now the sign, especially the integers in your grade 7. So the south and the west, so the south and west, remember class, south and west will give you a negative value while north and east is positive. So the 6 south here is -6, and to the north or pointing upwards, okay, that's positive. So -6 plus 10 will give you 4, and the net is still going up, so it's going up, okay, the direction. Now how about if you have 10 east and 20 north? So how do we check that? Okay, and how did we get 22.36? So this time here we use the addition of vectors already into components, and using this is, or answering this is actually through the the Pythagorean theorem. Okay, the same thing also for this. 5 to the left and 5 to the north, so it also gives 7.07. How did we do that? 5 square here, like Pythagorean theorem, 5 square plus 5 square, okay, then the square root of that, so it's 7.7. Now reminder class for today, so that we can go and solve our vectors later on, we need a scientific calculator because we will be using the trigonometric functions of the SOHCAHTOA, the sine, cosine, and the tangent. So here, let's proceed. How do we add vectors using analytical method? The sum of the two vectors in two dimension can be solved using the following equations. So here are our equations. R here is the resultant vector, capital R, bold R. And it is given as the square root of rx squared plus ry squared. Meaning to say, we have to get the resultant in terms of x and y. So later, we will be solving separately the rx and the ry. So whatever is our answer here, we will put it here in our equation 1. This is our equation 1. Okay, this is our equation 1. Then we have here our equation 2 is for the direction, tangent theta. So it's ry over rx. Next, so here your rx is the sum of all your vectors in the x component, and your ry is the sum of all the vectors in your y component. Okay, what are the steps for solving the magnitude? First is calculate the x component and y component using the equations. So we have, again, as I have said, we have to compute separately the x and y component. So for example, if we have two vectors, then we only have a vector A and we have vector B. So A and B. So we have AB for x and AB for y component. So AX here has this formula, A cosine theta, then BX is B cosine theta. This one. For your y component, AY is A sine theta, BY equals B sine theta. Your A and B there, okay, your A and B, they are our given vectors, okay? They are the given vectors, so we will just put that right away here and then get the sine and cosine of that. Then that's your components. So continue until the last vector. So again, if we only have two vectors, you will end A and B only. But if you have like 3 vectors, then you continue with A, B, C, like that. So note that the angle of the vector should be read counterclockwise from 0 degrees. So the steps again, after you add all components and y components using equation 3 and 4, you're going to calculate the magnitude of the resultant vector by using this equation. So again, if we have 2 vectors, then we only end up until B. If we have 3 vectors, then you will have your Cx, Cy. Then substitute the value of the equations 3 and 4 into equation 2. This is your equation 2. Your tangent theta Ry and Rx, where Ry is equivalent to Ay plus By plus Cy and so on, and your Rx is Ax, Bx, Cx and so on. Then take the inverse tangent of the function. So let us have this sample problem. What is the net force on the object if vector A is 10 newtons, 30 degrees, and vector B is 20 newtons, 110 degrees acted on it? So let us identify our vectors are, here we have vector A and vector B. So this is the diagram. This is your object. This is the object here, and there are 2 forces acted. Okay, this vector A here and your vector B on this side. Okay, so again, reading the direction. Okay, our theta here is very important. Must be, it says counterclockwise. So this is 30 degrees counterclockwise. Okay, now how about our vector B here? This is our vector B in this direction, and it's given here 70. But why is it 110 here? So remember, our perpendicular line here, this is 90 degrees. Okay, let's review our trigonometry. This is 90 degrees here, so meaning to say 90, this is another 90. So this part here, okay, this part here is 20 degrees, right? So this part here is 20 because the given here is 70. So 70 plus 20, that's actually 90. This is the perpendicular, that's 90 degrees. So meaning to say the 90 here plus the 20 here, so that makes our 110 for the second vectors. So solution first is to calculate the x component and y component of the 2 vectors. So again, this is our diagram. So we have to make a table similar to this so that we are guided already. So you have 2 vectors A and B. Then you are going to separate your x and your y component. So for A, Ax. For y component, A is Ay. So you have Ax here. Okay, so here you have Ax and then Ay. You have your Bx and your By. Then you just have to substitute Ax. A is 10 newtons given in the previous slide. So 10 Newton cosine, that's cosine, and then the angle of vector A is 30. Okay. Then you will just multiply 10 times the cosine 30. If you have a scientific calculator with you, when you press cosine 30, it will give you this value, 0.866. So the answer here is, your Ax is 8.66. So you do that also in your B or second vector, following the formula Bx equals B cosine theta. So your B there in the given is 20 newtons. Then cosine 110. Oh, as you can see, your first direction here, theta angle or angle is given in 30 degrees. Then the next is 110 degrees. So you just type, press cosine 110. It is negative 0.34. So 20 times 20 times 0, negative 0.34 is negative 6.8. Okay. Then you go for y component. You have your AY here is 5 newtons. Okay, sine 30 is 0.5. So 10 times 0.5. 5 newton. Then your BY is 20 newton sine 110. Then that's 18.8. Again, press in your scientific calculators. Okay, you have to practice. So you will add all the x and add all the y components. So your Rx is now AX plus BX. Then you substitute, your AX is 8.66, your BX is negative 6.8. Then it will give you a resultant in terms of x as 1.86. Then the same for Ry. Just substitute your AY 5 newtons, your BY is 18.8 newtons. Now for the direction, okay, before the direction, let's get now the resultant, because we already have answered our Rx and Ry. So substitute now your Rx and Ry, then square that, 1.86 square plus 23.8 square. So that's the answer for the square, and the final answer is this. Okay, so the square root of Rx, or 1.86 square plus 23.8 square. So square root of that is 23.8. This time is for the angle. Again, your angle is given as tangent theta equals Ry divided by Rx. So your Ry is given 23.8 and your Rx is 1.86. The tangent theta is 12.80, so we get the inverse of that. That means your theta is equivalent to the tangent inverse of 12.80, and it will give you this. So the resultant vector is 23.87 Newton with an angle of 85.83. So this is our final answer.
Thank you so much for watching, my dear students. I hope you were able to pick up today's lesson. How was it? I hope you can solve now and answer the problems given in your learning modules. If you have any questions, please don't hesitate to contact me or message me on my social media accounts as you see flash on the screen. See you on my next video lesson. Until then, bye for now!